Okay, our goal is to classify triangles by sides. Does anybody know what a scalene triangle is?
Like, I know what it looks like.
You know what it looks like?
Yeah.
What does it look like? Can you give me an example?
It's like that.
Can you, how about, that's fine, but can you give me like numbers for sides or angle measures or anything? Zach?
I think it's like none of the sides have the exact same measurement.
Okay, so no sides are equal, okay? And then something that we're eventually going to learn later on, dealing with the hinge theorem, if none of the sides are equal, then that means that there are no angles equal as well, okay? So a couple of ideas that you need to be able to understand. I'll draw some pictures to go along with this, okay? Number one, I can give you side lengths of, say, 5, 6, and 7. None of the side lengths are the same, so that's a scalene triangle. I can give you angles of, say, 50, 60, and 70. That's an example of a scalene triangle. Or I can give you tick, double tick, triple tick, and show you that that's a scalene triangle because none of the side lengths are the same. Okay? So you have to be able to understand and recognize based upon different pictures. Okay? So what's an isosceles triangle then?
I know that.
You know that
It's
one?
when two angles are equal and one isn't.
Okay, so two angles are equal or congruent. Okay, what else? What's another way to describe it? So scalene, we talked about no sides are equal and no angles are equal. Spencer said isosceles has two angles equal. What can you tell me about the sides? Yeah.
Two sides are equal.
Two sides are equal as well. Okay, or congruent. All right. So again, examples of some pictures. Okay, I can give you numbers. So like I can go a 7 and a 7. And the big thing that you have to understand is that the angles opposite them are going to be the equal ones. So like this would be 80 degrees and then this would be 80 degrees. And then the one at the top would have to be something different, the one in between the two equal sides. Okay? But I can also go like this and give you tick marks, tick, tick. Or I can just do it with the angles and say, hey, this angle is congruent to this angle. Okay? So different representations of an isosceles triangle. Okay? All right? Equilateral.
All sides are equal.
Do you agree with them?
Yes.
You agree. Okay? So all three sides are equal, okay, or congruent. So again, tick, 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 okay, or I can go like 4, 4, 4. Okay? So I can do it with numbers or with the congruent symbols. All right, so those are going to be the three ways to determine whether or not, you can classify based upon the sides, okay? But that also helps us with our angles as well, okay? All right, classifying triangles by angles. What's an acute triangle?
Less than 90 degrees.
Okay, so what do you mean? How many angles are in a triangle?
3.
Okay, so are you saying just one of them is less than 90 degrees?
And it can be more than one.
So more than one, so how many altogether?
All.
You saying all three are less than 90 degrees? That is correct, okay? So all three angles are acute, okay, or less than 90 degrees. Okay, so again, I think I did an example already over on the left over here of, say, like a 50, a 60, and a 70, okay? All right, now don't forget, okay, sometimes it can be an acute and it could be isosceles, like this one, 40, 80, and 80, okay? So we can classify them in multiple ways, all right? What about a right triangle? Let's start hearing from some other people. Let anybody think. What about a right triangle?
Equal to 90 degrees.
Okay, how many angles are equal to 90 degrees?
3 angles.
All three angles are 90? So that means we got 90, 90, 90. Now, based upon what, something that we already said, what's the sum of all three angles?
180.
So can 90, 90, and 90 add up to 180?
No.
All right, so
2 angles.
2 angles, but that means 2 angles, 90 plus 90 is 180. What would the third angle be?
Jesus.
0.
It's 1.
Okay, can you have a 0-degree angle in a triangle?
No.
No. Okay, so it can't have 2 90-degree angles, can't have 3, so therefore we're down to 1 90-degree angle, okay? So it has 1 right angle. Okay, and reminder that it has to, you know, have the box, okay? And don't forget that you can have an isosceles right triangle, you can have a scalene right triangle. All right, obtuse. So similar question, okay? It's going to have obtuse angles, but how many of the angles are going to be obtuse? He says 1. What do you guys think?
Makes sense.
1?
Yeah.
Well, if 2 of them were greater than 90s, then that means 90 degrees, and that means that you're already over 180 degrees. So there is 1 obtuse angle. Okay? Again, an example would be something like 100, and then we can go like 50 and then 30. Okay? All right, equiangular. Somebody else. What's equiangular?
I guess all angles are equal.
Okay, he says all 3 angles are equal or they are congruent. So don't forget, I can give it to you in terms of numbers, or I can give it to you in terms of symbols. Okay, now if I'm going to do it in terms of numbers, what would the measure of all 3 angles be?
60.
Do you agree that it's 60?
Yes.
Ryan, what do you think?
Yeah.
Yeah? What's 180 divided by 3?
60.
60. So 60, 60, 60. Okay? All right, so think about the next question. Okay? Equilateral. An equilateral triangle is always, sometimes, never equiangular. Always, sometimes, never equiangular.
Always.
Always, always. An equilateral triangle is always, sometimes, or never.
Always.
Always. All right, so they will always be, so in over here, we already know that this has to be 60, 60, 60, and this has to be tick, tick, tick. Okay? So what would be the best name for an equilateral or an equiangular triangle? It froze again. Okay. Best name is that it is regular. What does regular mean again?
All equal angles and sides.
All right, all the sides are equal, all the angles are equal, and we just said if it's equilateral, it's equiangular. If it's equiangular, it's going to be equilateral. So the best name, hint, 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 for the chapter test, is that you're going to say regular. Okay? All right, now what we're going to do is we're going to classify. Sometimes you can classify based upon sides. Sometimes you can classify based upon angles. Sometimes you can do both. Okay? So in the picture on the left, each of the tiny triangles here, I am going to tell you each of these little ones are equilateral. So can someone describe the big triangle, the green, the blue, and the red all together? I heard equilateral, regular.
Yeah.
Sammy, what do you think?
I have a question.
Yes,
So what regular means is equiangular?
No.
correct. It means both. Okay? So what do you think about this triangle? If I tell you each of the tiny ones is equilateral. Regular, regular, equilateral, and it is correct. Okay? Regular would be the best name for it. So it's a regular triangle. Okay? All right, the Bermuda Triangle. They gave us the distances between the 3 cities. Okay? Well, how would you describe the triangle based upon the information given?
Scaling.
Scaling. Can we say anything else? Like,
No.
right, obtuse, acute. All right, so where are the angle measures? How do you know they're acute?
Like all the measures are different.
But we never assume based upon a picture.
Because it doesn't have the angle.
So if it doesn't
Like,
have
you
the
can tell that it's
angles,
less than 90 degrees.
if they don't give us the angles, can we assume?
No.
The answer is no. So the only thing that we
Tell me
can,
it's less than 90 degrees.
you can, how?
Because it's not, it doesn't have the square. And it's
If it had the
not-
square, it
Okay.
would be.
All right, so our goal here is to classify the triangle, given the coordinates. Best idea, always think about drawing it out. Okay, so I know that -2, 2 is in the third quadrant. Okay, I know that 1, 6 is up here in the first quadrant, and 4, 2 is also in the first quadrant. If I connect, and connect, I form a triangle. How can I classify the triangle? What ideas can I use? Ooh, say that louder. She says use the distance formula. If we use the distance formula between the points, we can figure out the lengths of the sides. All right, so we're going to split up the work. We got? All right, so the horizontal line, you guys had the first 2 points. What'd you get for your distance? What did we get? What'd you guys get?
I haven't been able to concentrate.
What'd you guys get? 6. All right, so you should have been able to get 6. You guys had the easy one. All you had to do was go from -2 to 4. That's 6 distant points away. All right, middle one. 5. Okay, table's at the end. All right, so if we have side lengths of 5, 5, and 6, what type of triangle is it?
Isosceles.
Can we describe this triangle based upon its angles?
Yes.
Yeah?
No, we don't know them. Well,
No, we don't
Never
know that.
assume.
We do not know.
Never assume.
Okay?
Never assume.
Yep, okay, so it's an isosceles triangle, all right? Next, vocab is gonna help us with the theorems that we have coming up, okay? So I'm gonna give you a triangle, and I'm gonna extend one of the sides, and what you have to understand is that the interior angles are the angles inside the triangle. The exterior angles are the angles on the outside of the triangle, okay? If I extend any of the sides, I would get another exterior angle. And if I were to extend this last side, I would get another exterior angle. All right, so some simple concepts to talk about first. Number 1, what is true about the sum of the interior and the exterior angle? They add up to be 180 because they form a straight line, okay? Number 2, okay, we talked about this already. What's the sum of the 3 interior angles of a triangle? 180 degrees. Make sure everybody knows that. Okay, that's super duper important. All right, so there are triangles on your desk. We're going to do a little activity. Let's take a look at problem A. Problem A. Okay? You got to find the value of x. How are we going to do that? How are we going to find the value of x?
Wait. Instead
Summary.
of like all the 3 sides add up to 180?
How about the 3 angles?
Oh, yes.
62 plus 48 plus
Plus
x equals 180.
62 plus 48 plus x equals 180, which means to solve for x, we're going to do what?
Subtract.
62 and subtract 48. Do that, tell me what you get.
And x equals 70.
Okay, we got 70 from 2 different tables. Everybody agree on 70?
Yeah.
All right, so I like to take things a step further and ask you to review. Okay, what type of triangle is that?
alien.
Anything else?
Acute.
It's an acute scalene triangle. Usually you do the angles first and then you say the sides. So it's an acute scalene triangle. Okay? All right, we don't have time to do all of these, so let's skip over to C. What are you going to do here? Amanda?
X plus 5 plus 3x plus x equals 180.
I like it. How many x's altogether?
3.
Try again.
5.
5 x's.
What?
Well, 1 plus 1 plus 3 is 5,
Oh.
right? Subtract the 5. What does x equal?
35.
I heard 35.
I
aggravating.
I'm gonna go with Summer and say
What's
35.
175 divided by 5?
What's 175 divided by 5?
Ross, can I get your calculator?
I got a 35 over here.
35.
35. So x is equal to 35. Okay? If I plug that back in, that gives me a 35-degree angle. That gives me a 105-degree angle. And that gives me a 40-degree angle. What type of triangle is this?
Acute scale.
It's an acute scalene, I
It's
heard.
an obtuse scaling.
It's an obtuse scalene because of the 105-degree angle. Okay?
Oh, never mind.
Okay? All right, one more. All right, so on example 3, concept that you need to understand is that the three angles, 2x plus x minus 6 plus 90 for the right angle, add up to be 180. If I subtract the right angle over, I've got 2x plus x minus 6 equals 90. What I'm trying to show you here is that the two acute angles will always add up to 90 degrees. The two acute angles of a right triangle will always add up to 90 degrees because 90 plus 90 will add up to 180. Okay? So our corollary, the acute angles of a right triangle are complementary. Okay? Reminder, that means they add up to be 90 degrees. Okay? So just reminders there. You don't have to go all the way up to the 180 like you did in the, like I showed you up there in the first equation. You could just use the second equation, just add them up to 90. Okay? All right, last page, last theorem that we got to talk about. Okay? Exterior angle theorem. I'm going to take a look at example A here, and I'm going to show you something. Okay? Go ahead. So you're supposed to understand that the 50 plus the 130 adds up to 180 degrees. Okay? All right, next. What's true about the 4x, the 50, and the x?
They're all up to 180.
All right, so 50 plus the x plus the 4x plus 10 equals 180. Okay? All right, so here's what I'm going to do. I am going to subtract the 50, and that's going to leave me x plus 4x plus 10 equal to 130. What do you notice? Yeah.
We have combined like terms.
Okay, I did that on purpose, though.
Oh, okay.
Okay? There's a reason why I got rid of only the 50. What do you notice? Give you a hint. What do you notice? Go ahead, Astrid. All right, the sum of these two angles here, the x and the 4x plus 10, will always add up to the exterior angle. And the reason is, aren't they using 50 in both equations?
Yes.
Yes, so they're both using the 50 to get to the 180. So here is our theorem. The exterior angle, in this case, the 130 degrees, so the exterior angle is equal to the sum of the two non-adjacent, the adjacent angle is the 50, the x and the 4x plus 10 are not next to the 130, so they're the two non-adjacent angles, non-adjacent interior angles. Okay, and you see that right here. The x and the 4x plus 10 are the two interior angles. They add up to equal the exterior angle 130. Okay? And the reason is because of that concept of the angles all adding up to 180. All right, in example 4, can someone create an equation using the concept that we just talked about? Go ahead.
70 plus x plus x plus 2x minus 5.
Oh, wait, where'd you get the other x?
Well, like, because the angle should be next to
This angle? This angle? Do we know the measure of that angle?
No.
Okay, so what did you make it?
X.
You just made it an X?
Yeah.
Can we just make it an X?
Yeah, right?
Can we do that?
No.
No, we cannot do that, because we don't have any information to make it an X. This is already an X.
Well, then 2x minus 5 plus x plus 70 equals 180.
So you want to add this, and this all equal to 180. All three of them, even though one of them's on the outside.
I know the equation.
You know the equation?
70 plus x equals 2x minus 5.
All right, so it's equal to 2x minus 5. The two non-adjacent interior angles equals the exterior angle. That's the concept, okay? And then what we'll do is we'll solve for x, and we'll show that it works, okay? Solve for x. Tell me what you get.
75.
She got x equal to 75. We got somebody to
She's
second
right.
that?
Yep.
You agree? You agree? Okay, so let's plug that back in, okay? So that means that this angle up at the top is 75. What's 2 times 75 minus 5?
145.
145, okay? So now the question is, does 70 plus 75 add up to 145?
Yes.
It does, so it works. So the two non-adjacent angles add up to equal the exterior angle. That's the big concept that we have to understand, all right? Questions?